maybe Gao wanted 4 days for the holiday. 3 days not enough. Okay, let's see. DIFC workbook physics. What electric field? What number? We did this one. Oh, we're only on the second. Okay. Okay, that's fine. I thought we did more. Come on. So much free space. Yeah. I only use this laptop for class. So. Come on. Come on. Here we go. Okay. You have that. Right. So, 2 formulas to look at, really. Okay, so the first thing. Different charges will produce different electric fields. And we have to look at 4. So we'll look at a point, a sphere, parallel plates, and a dipole. So I'll explain each of them as we do them. The first one is a simple one. If you just have a point charge, so that means if you have like a negative, an electron, then the field points in. Or if you have a positive, the field points out. Because remember we said we have to imagine how a small positive charge would move. So that would move in and that would move out here. So in the exam, they could ask you to draw a point charge field. They might say, draw a point charge field for a negative and a positive charge. So this is a point charge. So if you can draw that in your notes, please, point charge. Yeah? Okay, good job. Right. Do you know this word? Spherically?
No.
Do you know the word sphere?
No.
Great. So sphere means like a ball.
Okay.
So this is example of a spherically symmetric charge, a positive charge. Now do you notice how it's the same as one positive? So what we're saying is, if you have many positive charge in a sphere, then it's like one big positive charge. So it's the same idea. So this is spherically symmetric charge. So in this picture, there's 1, 2, 3, 4, 5, 6, 7, whatever. There's like 8 protons or something like that. Okay. So if you can draw that one now, it's a bigger one. Oh, no, you need to make sure you have the names as well. So this one's called a point charge. Did you write that down? Okay. Yeah, and there you go.
And this is
spherically symmetric charge.
Spherically.
Yes, spherically symmetric charge.
How do you plan your holiday?
I don't know. What will I do for my holiday? I have things I need to fix in the house. That's not exciting. And yesterday I cut the grass.
Cut the grass.
That's not exciting.
I feel exciting. Oh.
Ah, Khalifa, what happened? How come you're late? Alright, you got that?
Yes.
Did you draw it?
Yes.
Okay. The next one parallel plates. Now, I hope you know this word from maths.
Oh, sure.
What's sure? Yeah, very good, very good. Parallel plates look like this. So it's important.
So what is oh, I know.
Plates are like this.
Yeah.
Now, it goes from positive to negative, but at the end, it actually bends a little bit outside.
Okay.
Yeah. So make sure in your picture you do a little bend.
So
Yeah.
normally we just how to say know the limit and
Limit.
a long plant.
Ah, yeah. Normally, yeah. But if they ask you to draw it in the exam, you should draw it like this.
Okay.
Got that? Through that? Yeah. Okay, so that's parallel plates. So the fourth one is called the dipole. Come on. Loading. There we go.
Okay.
And this one's called the dipole. Now, I know you have this one from yesterday, but I need you to draw it again because I need to add something to these diagrams in a moment. So if you can draw this one again, the dipole.
Why did you know the yesterday?
Why?
Yeah.
What do you mean?
Yesterday's chemical lab.
Ah, you did dipole? Oh, did I say yesterday? The last class.
This
Okay, fine. Fine.
is the same.
It's the same, yeah. It's the same as last time. Okay, so we have this thing called equipotential. Now, I'll explain it here with a picture. So I can draw this. Right, so here's the ground. And this here has potential energy. And this here will have potential energy. But this one will be less potential energy. Okay? Everywhere on this line
The same.
is the same potential energy. So this line here is called, if you look at the word here, equipotential. Now, what does this part here mean? Equal, yeah, equal. And this part here, potential, means potential energy. So, if you had the ground here, then you would say the equipotential lines are like this. On all these lines, the same potential energy. This line is different to this line, but everywhere on the line is the same potential energy. So this is called the equipotential line. The equipotential lines, come on, refers to the part of space where every point in it has the same potential energy. That's the definition. And I drew them. But what I'm going to do next is, for the 4 pictures, we'll draw the potential lines in a moment. But first, if you can write that definition down, equipotential. You got that? Yeah? Yeah. So let's draw them now. So the first one was the point charges. So, for example, if you have a positive or a negative charge, well, the equipotential lines are these lines. And the same for the negative. And it's also true for the next one, the spherical one. So if you have a different colour pen, like a red pen, you could add these in. Okay, so here are, now these are 4 different pictures, okay? Yeah. Got that? Yeah. So the next one is the parallel plates. And it doesn't matter if you have positive on the top or if you have negative on the top. You could probably guess the equipotential lines are these lines. Just horizontal lines. It's also. If you want to add this now to your diagram. Got that? Yeah? Okay. And then the next one is the dipole. So, if you look here, first you have a potential line here. In fact, everywhere on this line there's 0 potential because it's balanced. But you also know that there's circles around these. So what happens is it looks like this. To draw, but you get a picture like that. That's the equipotential lines. It is hard to draw. Got that? Yeah? Continue? Yeah? Right, so when a current is passed through two conducting plates, separated at distance d at a voltage V, then there's an electric field produced. So the way you make the field between the parallel plates is quite simple. All you do is you pass a current through it. And this causes the field to appear. Okay? We'll call this distance here D, and we'll call this here voltage V. And the strength of this field is equal to the strength, I suppose if we want to be clear, the strength like here at the top is V over D. V over D is the formula here. I guess you could draw the picture too.
I think we should have a switch.
Okay, Ben, you're right. We should have a switch. We should be safe. There. Better?
But I don't like it.
Okay?
I think it's the same something we learn.
It's similar. What we learned is E equals F over Q.
This
Yep.
is yesterday.
Yep.
Oh,
So what you can do, if you like, is you can actually put them together.
oh.
What are you looking for?
Okay, you can continue.
Continue? Okay. Now, what about if you have a point charge? So if you look here, you have a point charge and you have a field here, and you want to know how strong is it here, and this will say small q. Okay. So the formula for the electric field strength here depends on how far away you are, so we'll call that distance d. So the electric field strength, you can write it as two formulas. You can write it like this: 1 over 4 pi epsilon 0 big Q over d squared, or you can just write as big K Q over d squared. Well, where have you been? I haven't seen you in days.
Sorry.
And you're late. Why are you so late?
Because I missed my bus
Ah, but where were you last class?
last
On Wednesday, and Tuesday,
home.
and Monday.
Home.
Why? Yeah.
I need to go the rest. I think.
Oh,
Sorry.
summer. Right. So, this thing here is a constant, which is on your calculator. So this one is on the calculator. But you don't have this on your calculator, do you? So you can use this formula, and this is just a constant as well. And the K is, well, actually I have it here. You can use, we can use this formula because I give you the epsilon 0.
So, okay.
Now, but if you want to use this formula, the K is 8.99 times 10 to the 9 for this one. And in this formula, the epsilon is 8.85 times 10 to the minus 12. So you can use either formula. Now, as a small question, what I want you to do for me is just to tell me what the units are for these constants. So what's the units for k? You can work it out. What's the units for k? I want the units here now. You don't need to write anything? I don't think you could do it in your head. The units for k? Do you know what to do? Okay, look.
I want to guess.
No don't. E d squared, look, Ben. E d squared over q equals k. E is newtons per coulomb. D is meter squared. And q is coulombs. So there you go. The unit is Newton meter squared per coulomb. Oh, sorry. I wrote coulomb.
Coulomb is 3.
Oh, sorry, you're right. Newtons per coulomb, meter squared, and coulomb. So it's Newton meter squared per coulomb squared. That's the units. Yeah. Okay, you should write those units down.
What's E?
Which E? This E? Yeah. Electric field strength, like what we did in the last class.
Okay.
So you can also use this formula, but that only works if you know the F. If you don't know the F, then you have to use this formula. Yeah? Yeah, continue? Continue? Yes? Okay. Right. Here is a question. Two horizontal plates have a potential difference of 200 volts. Okay, so you have two plates. And this here is 200 volts. And this here is 1 centimeter. And the top one is positive, the bottom one is negative. How long would it take half a milligram particle of 10 to the 10 E to fall from the top to the bottom? So, you have a small charge. Its mass is 0.5 milligrams and its charge is 10 to the 10 E. And this is going to fall. And my question is, how long? What is the time it will take to fall? So, I'll give you a little hint. I'll let you try this, okay? This problem is UVATS. Do you know U? Yeah, well, it starts at rest. Yeah, 0. You know U, okay? Do you know V? No. Do you know T? No. This is what you want. Do you know S?
1.
Yes. And you know this one? Yes. So if you just find A, it's finished. And how can you find A? You can use F equals MA. Do you know F? No, but you can use the formula E equals F over Q. But do you know E? No, but you can use the formula E equals V over D. So you can get the E, then you can get the F, then you can get the A, then you can get the T. So you have to go, first you get E, then you get F, then you get A, then finally you can get T. I think you can do this.
Sure, but I think we should step by step. We should do a simple example.
This is too difficult?
Okay, fine.
Alright, well, you're right. Okay, Ben, you're right. I'll give you a simpler one first. Simpler. Okay. 100 volts. Electron. Positive. negative. I want to know what is the force here. And remember, the force equals the weight plus the force from the field. So there's two forces here. Okay? Yeah, what's wrong? How do you get the weight? mg. How do you get this one? How do you get this one?
E.
Yeah. So QE. How do you get this one? V
D.
over
D.
D. Do you know V? Yeah, let's make this 1 centimeter. Okay, we're going to calculate. Give me the F. I think you can do this. See, Summer, you're confused because you missed so many classes.
Yeah.
Yeah. And did you watch the videos? No. So what were you doing at home? Nothing. Right?
Q is charge.
Yeah. And this here, Ben, is 1 electron.
So how to calculate the Q?
I gave it to you. It's a constant. I gave it to you this week.
This
Mm.
is
And I gave it to you when we did electricity, I think. In the electricity chapter.
oh, I think I also missed that class.
Oh.
Oh.
I think we can without the mg, just w weight. It's too small.
Yeah, so the mg kind of disappears. This is so small. So this here is mg plus qe, which is mg plus qv over d. The m is, what's it, 9.11 times 10 to the minus 27.
31.
Oh, 31, thank you. 31. And the g is 9.81. The q is 1.6 times 10 to the minus 27? No, minus 19.
90.
Times 100 over 0.01. Now, if you can compare these, there's a huge difference. Okay?
Double.
Yeah. Like, this has no effect on this because the power compared to this is so much smaller. So really, we just need to worry about this part, which would be 1.6 times 10, and then this is 2 for minus 15 newtons. Okay?
So 1.602.
Okay. Okay, Ben. Ah, yeah, but we have to use, remember, 3 significant figures. 1, 2, 3.
Oh.
So 1.6 is the final answer. Okay? Now, feel ready for a harder one? Yes, you do. So let's go back to this one.
Okay.
So this is half a milligram. Its charge is 10 to the 10 E. It's 200 volts. It's 1 centimeter. And this time I want the time.
Okay. Let me try. Why we can get a half energy? Just
That's the mass. It's a small particle.
I mean it's half electron.
No, it's not half an electron because it's many. And it's not an electron because it's positive charge.
Oh,
It's a molecule.
molecule.
It's a molecule, yeah. It's a molecule of positive charge and it's half a milligram.
Okay.
Don't worry, it's not half an electron.
Oh yeah, it's molecule. So okay, Q is
1010 E.
oh it's
Got an answer, Ben?
nearly.
Nearly, okay. got answers somewhere?
Maybe, I don't know.
Khalifa? Let's have a look. So, oops. So, let's put down our information. U is 0. V we don't know. A we'll know in a minute. T we want. S is we could say minus 0.01. It doesn't matter. You can, whatever. So, E is 200 over 0.01, which is 20000. Fine. And then F equals QE, which equals 2 times 10 to the 1, 2, 3, 4, and 10, 14 E, if we sub that in. But F is also MA. So if we divide by the M, so that's 2 times 10 to the 14 E over 0.5 times 10 to the minus 6 kilograms. Did you say 10 minus 3? We need to make this kilograms. So 0.5 times 10 to the minus 3 grams is equal to 10 to the minus 3 over kilograms. So 10 to the minus 6. So that's the A. Yeah?
M, what is the M equal?
One sec. Let's just write this down. There's the M. That's the M.
It's half mg.
Half a milligram.
Milligram.
Yeah. Yeah. Can someone tell me what that A is? Oh wait, no, stop. No. No. Not right. Not finished. Because there's two forces. There's that plus mg. So when I divide by m, I need still here plus 9.81. Now that's going down, so it should be a minus, because if this is positive and that's positive, it's being pushed down, and gravity is pulling it down. So the A is actually going to be minus bracket 2 times 10 to the 4 times 1.602 times 10 to the minus 19 over 0.5 times 10 to the minus 6 plus 9.81. Okay, now let's see what the A is. What is it?
I think I got it wrong. You know,
6.4 will be times 10 raised to power 39.
What? You must have typed it in wrong. Yeah, it's power minus 19. There we go. Minus 73.89. Yes? What's wrong, Ben? You didn't get this? Well, that's what it is, I think. Yeah? 2, 10, where's this thing? Yeah, that's good. So, how could I get the T? I could say S equals UT plus a half A t squared. So t would be 0.02 over 73.89 square root. 0.0165 seconds. 16.5 milliseconds. Yeah? Continue? Yes? Okay. Right. Okay. So this one here, an electron is 2 millimeters from 3 protons. So you have 3 protons, proton, proton, an electron here, and that distance is 2 millimeters. So of course there'll be a force. This is going to be pulled in here to the 3 protons. Now the reason it's being pulled in is because there's an electric field coming out from the protons, and this pulls the electron in. So there's an electric field here that pulls the electron in. Okay. My question is, what is the force here?
QE.
Yeah, use the other formula. Right, just before you do that, I want to add in Ben's question. Here you go, Ben, just for you. A student named Ben puts... We'll do our first example. What was it? Puts an electron between 2 parallel plates of potential difference 100 volts and 1 centimeter apart. Yeah? The first example we did.
Oh.
Where is it?
No.
Huh? What was the information for the first question we did?
So,
Guys, come on. What?
The last question.
No, the first question.
First
the
question.
simple.
The simple question. Yeah, what was the information?
100 watt and 1
Centimeter.
centimeter.
And what did I ask you for? The force?
Yeah, for us.
Okay. And was it positive on the top?
Positive, yes.
Positive.
No. It was?
Yes, positive.
Yeah, it's positive on the top and negative.
Are you sure?
Yes.
Are you sure?
See.
Where is it?
Now.
Down. Yeah. The second one.
Orange.
Ah! A positive on the top? No, I'm sorry. That was wrong. Well, I meant negative and positive, because I wanted it to be pulled, to add these together. I wanted it to be pulled, so it was just negative and positive. But this is right. I just wrote it wrong here. Because I want the 2 forces to add, the gravity and the field. Okay, so I'll just say, a student named Ben puts an electron between 2 parallel plates, potential of 100 volts and 1 centimeter apart, with the negative plate on the top, where the electron is initially placed. What is the force acting on the electron? There now. So students next year, Ben, they can see your question in class. You should feel very proud. Okay. Where's my 3 things gone? Down? Yeah, okay. Right, I'll give you a minute to try this. I think you can do this one. So you need to use the other formula. I'll write it here for you. E equals KQ over R squared. And I'm looking for the F here, okay? Oh, sorry, well, yeah. By R, I mean the distance, so Did I use the letter D? Then D it is.
So we use which just electron Q.
Yeah, you tell me, which do you use? The electrons or the protons?
Electron. Proton.
Why?
Bigger.
No. Because the protons are what's making
Oh.
the field.
Oh. Okay.
Yeah?
So is 3.
So what you can do is you can call this one small q and this one big Q.
And 3 act together.
Yeah.
Act together.
Add together, yeah.
So what is the key?
Did you not write it down, Summer? I told you.
No, the key is 8.99. Oh yeah.
So why did you ask me?
Sorry.
Ah, you don't listen to me. Break my heart.
And you know F equal EQ,
Yeah.
so the Q again proton is electron.
Because it's the charge of the thing that has the force.
We want to know what's the question.
What's F?
Oh, what's the
This F.
electron
Yeah.
make the F
Electron feels the F.
feel?
Feel. Feel.
Oh, but I think the electron feel the F is proton made.
Yeah, but if I say this formula F equals MA, that M is always for the thing that has the A and has the F on it. So if I say F equals QE, that Q is always for the thing that has the F. For the same way the M and the F are on the same thing. Yeah?
I think I know.
Okay. Got an answer? So here you have F equals QE, and E is KQ over D squared. So this is equal to KQQ over D squared, which is equal to 8.99 times 10 to the 9 times 1.602 times 10 to the minus 19 times 3 times 1.602 times 10 to the minus 19 over 0.002 squared. Okay, so what's that?
1.73 times 10 minus 22.
22 newtons. Yeah. It's okay. Continue. So, next is for you to try some. Let's see. 4 questions. And you can see they are kind of hard. Right? They're a little hard. So in the first question, if you can just look up, I'll just draw it for you. You have an electron orbiting a proton. So you have a proton and you have an electron. Okay. And the proton makes an electric field. And of course, there'll be a force here. Okay.
D.
And the D, they tell you, is 10 to the minus 10 meters. Yeah? And my question is there. So I'll let you try these for a few minutes. Yeah. They're a little hard. So you can try them now for a few minutes.
A is what's the electron field is E?
Yeah, the E here. Yeah. Because the other way you can think about it, Ben, is like this. There's also an electric field around the electron. So you could think of an E being here. But for the beginning, I want the electric field strength at the electron's position.
Oh, it's electron.
I want the field caused by the proton where the electron is. So for the first part,
But it's caused by proton.
yeah, the field caused by the proton at the electron. You know, because Ben, if you're out here, the field, the E is smaller. So I want the E here, caused by the proton. So which Q do you use? Do you use this Q or this Q? Well, it doesn't actually matter because it's the same, but it should be this one.
Okay.
Yeah. Go on, try your best. Try your best. Yeah.